Hello, this is Michael from the CCNB, and today I will tell you how to transform your MRI scan into a 3D printable file so you can have a cool 3D printed brain like this in the picture. And what you need for that is, of course, a computer. And if you have DICOM files, you would need to change them in IFTY files and then zip them with gzip. You can do that simply with MATLAB, like you've done probably. You can, of course, use Python for that. So these are like the only prerequisites for my pipeline, and the rest will be explained in the video. And good luck. And I'm here to give you a supplementary video tutorial on how to 3D print your brain and go from MRI data to a 3D printable file. And yeah, let's just begin. First, you want to open a browser. You want to go to GitHub and then my name. And here you can find my GitHub account. There you can find, and pinned in here is the 3D Print Your Brain repository. You want to go on here. And what we actually have here is all information that you need. So if you don't want to watch this and you want to do it a bit quicker, you can just go through here. And also if you are, I think, a bit more familiar with Git and all the other things, you definitely don't need to listen to this. But we are just going to follow along this table of contents and do all of the steps that I've already described in here. And by the end of it, we are going to have a 3D printable brain file. And okay, so we can see this is a GitHub project, and GitHub projects are often meant to be cloned and copied to the PC. And to do that, we need Git. And for that, I will just install Git. Windows. I don't know, you don't install Git very often. So let me go in here. Windows. I guess. Pick everything recommended and see how it turns out for us. Now we will wait for the install. Okay. Follow the table of contents, of course. And we will first install Docker Desktop. And for that, I'll click here, find it in the wiki. And this will link me to the place where I can download Docker Desktop. Download for Windows. We are on a window that we have Docker Desktop installed. For the exe file to install it, we're going to click on it and install it as usual. Yeah, now that we are finished with the installation, it says that we have to close and restart Windows. So yeah, now the computer is back up and we get this notification from Docker Desktop. And yeah, I'll just accept the service agreements and I'll just go to this desktop and use the recommended settings. And I will sign in. Okay. If you're very new to Docker, I would recommend you to do these tutorials. How do I run a container? And run Docker Hub images. And what is a container? How do I run a container? Whatever. We've just had that, and I think you don't need to know much about volumes, but these two are pretty good, or these are 3 tutorials that can help you kind of get into what actually is Docker and the idea behind it. The idea behind it, I can summarize it quickly, that if you have certain applications which only, or certain systems which only run on Linux or only run on Mac or only run on Windows, and you can put them in a container, and the container is basically an OS, like an operating system, which hosts all of the applications. So when you have an application which needs a certain operating system, you can just always put in a container and then run it on almost any PC that you have, because of this container thinks that it is inside of the designated OS and not just on any computer. Okay, so but I've done these tutorials, so I'm not going to do them again with you, and they're not really there for you to print the brain. I'm just going to sign in. And second one is pulling the Docker image. And here we have the image name. You can just copy it. And here I can just type in the image name. I don't even have, yeah, and then I'll pull it. I'll press on the pull button. If you have any trouble getting the Docker engine to run, sometimes it says, oh, Docker engine does not run. Then I had like these issues on my other PC when I first tried it, and I've put it in the wiki what might help. Here I found like a good video which mitigates the issue if you are on a Windows machine. But for me, like this time, I just had to restart my PC and then start it again, and this was enough. So we've now installed Docker Desktop. We've pulled the Docker image, and we can see the image here at Docker Desktop Images. We have no containers yet. We'll do that in a bit. And now we will continue with the next step, which is downloading the free server license. The license is just there to make it run. So you can still have the software, but it won't actually do what you want if you don't have the license. Here you will just get sent to the site, and you have just to the most important part is the email, because when you will input that, you'll get an email with a .txt file, just with it's just called license.txt, and it will have a key inside. And what we want to do is to take this license and put it into a specific folder so the free server can run. We'll do that. I have already done that. I'm not going to request a second license because it works across all PCs. I'll just have a tutorial folder, and into this folder I'll put my folder with my free server license, and here's just the license.txt file. And when I open it, it just will be some random numbers. Well, we can skip this. We can say we downloaded the free server license. I think you will have no problems doing that. And then we can actually use Git, which we installed, and clone the repository. Copy this link. Now open a terminal in the tutorial folder. You don't have to call it tutorial, but for me it's nice to see why I have that. And now we just type in git clone and the link of the GitHub. And everything worked as intended. And now we have a 3D print your brain folder inside here. And yeah, so let's see what the next step is. The next step is setting up our files. So we want our files to have a specific structure. This is because we are copying stuff and putting in running scripts. So we want to have this specific folder structure so everything runs smoothly. But the structure, it is 3D print your brain, then the license and the README, but it's not the free server license. It's just like the license which you cloned. And here we will have print your brain _mount. And this is one folder which we will then attach to the container, but we'll come to that. And inside we have scripts, but so this is as intended. And in the scripts folder, we have the script.sh. So we now need to generate a new folder called subject. And we will do that. New folder, subject 001, like that. And folder, which is obviously empty, we will create two new folders. One is called input, and the other one is called output. Script, because into the input folder, we want to put our T1 image. One of the requirements for this whole thing that you have a T1 image. And the T1 image should be a nifty file, be zipped. So if you, I don't know, it's free software, so you can just gzip your nifty file and then put it into the pipeline and figure out how to make nifty files out of your DICOM files and how to zip them. On this one, I'll get it and put it into the input folder. The same structure now. Let's see, scripts, which has the script.sh. We have our subject, and we have put an output, and in the input there we have our compressed nifty file. You can see we have to run the container. But before we do that, and before getting and installing something like VS Code, you can go to Microsoft Store and then just search for VS Code. And then go here onto download or onto install. I have already done that, although you can continue. So what this the opportunity to do is to go into we have, which is called 3D Print Your Brain, and go to and open it in VS Code. You can sometimes go to more options and then you can see open with code, but here we can't see it. So we can open it in terminal and then type in code dot, and this should open it in code. You can also manually open VS Code and then go to here, open folder, and then open it. So terminal, so we can type in the command, go to new terminal, and now we have a terminal in here, and we can also see the rest. It's very easy for us to see the folder structure and to look into the scripts. That's why we kind of use VS Code and to change them while we are operating in the terminal. What I want to do is to copy this thing and paste it into our terminal. And of course, this wouldn't just run on its own, because if you look closely, it says here path to your PYB underscore mount. And here we have to input our own path. And we can do that by going to the folder, by the 3D Print Your Brain folder, and going to print your brain underscore mount and say here copy as path. If you don't have that, like if you're maybe on Windows 10 or Windows 7 or whatever, you can also go into this folder and then here you can copy this thing. Yeah, I'll just do that, do the normal type of way now. And then Control C, Control V, and this should be the place where we are now and the place where our mount is. And here again, so I can explain it in a short way, we're just using Docker and to run this image. We are running it on a Linux and we are doing it iteratively. You will see that soon. That means that we can interact with it and it doesn't just close when it's finished doing the thing, but we can type in stuff into the terminal. VFlag is giving us an opportunity to add our own folder to that container. It's not copying the folder over, but it's literally linking the same folder to the container, which is important. And I'll explain why, or you will see why soon. And here we'll do the same with the path to the free surfer license, because we want the license also to be linked to the containers, because the free surfer software is in the container and not on your PC. You also don't have to put in the paths in quotation marks, but if you have spaces in your folder names or some other irregular stuff in your folder names, then quotation marks help to make it run. I've had that issue. Just press enter. This should work. And if it works, you can see the terminal. This is the terminal inside the container. Like that. If we open Docker Desktop, you can see in containers, it opens now a new container. And whether your mounts worked, here we see that we have the scripts in here and the subject. We have no folder called printyourbrain_mount because the home is now representing the folder here. And something similar goes into for the FreeSurfer license. We have put it in the right place at FreeSurfer.6.00. And somewhere here is then the license, and FreeSurfer can just use it as it would normally do. See that we have a folder called license.txt, and maybe we want to add in the license and not the folder. So you'll see me do this again now, and we'll just delete this container, which is not here up. Yes, arrow upwards, you can just copy the thing that you had, and instead of getting the folder to the FreeSurfer license, we will directly get the license folder called license.txt, where we have the license, but we just have the license. And let's check whether it is the case. Look into containers. It now has another name because it's another container. It's totally new, no relationships to the old one. Let's look. We can see that we have then the FreeSurfer, and here we have license.txt. This is how it's supposed to be. Sorry if you've done the mistake with me. And delete this script and run the script. And to run the script, I have written some directions down, which should help you. First, we should go to home/scripts and D home, because this is how you get around. With CD, you can get around in a terminal. Scripts. If you're unsure, you can always press Tab and see whether you're there. And we can also press LS to see what's in the folder. And in that folder, we can see our script file. And that is very good, because we want to run the script file. And to run that, we also need to activate it. And to activate it, you type in chmod +X and then .sh, the name of the script. And then we have to specify the variables. What do I mean by that? Is that we have here this one block where some things are defined. For example, the output folder, we want it to be output. And the main directory is home. But you can always change that depending on the system. But in our case, we have bounded to home here with our volume. So we know, okay, it is right. we have our subject 1, and this just means that this will be our folder of the subject. And what we will type in to run it is script.sh, name of the folder. So we have to remember that our folder is not called sub001, but only subject 1. Yeah, so this is one thing to consider. But here you can just see some things that you need to run the script. And here we reference our T1 file, ending of T1 and a small w. And we can look at our file. It has a T1 but without a W. So this is the perfect opportunity to delete the W here and here, and then press Ctrl S to save it again. And this is the cool thing, that the thing, like the folder and the files, are on your host system and not in the container, so we don't have to go around and edit it in the terminal, but we can just edit it here, and it automatically changes on the container because it's the same file, it's the same folder, and you don't have to pass it on and copy it or whatever. So we can just change it to fit our needs, and should run without problems on your PC. But there's one thing that can happen, and if it happens, what we need to type, script.sh subject is 001, and here it says the script cannot execute the thing because like file not found. Reason for that is this is encoded in Windows, so when we pulled the thing, like when we pulled and cloned the directory, we have automatically converted it to the Windows settings, and now that we've put it into the Docker, it is still in the Windows settings because it is on our Windows machine. Most of the time it doesn't happen, but sometimes it does on this computer. But we can just go to the bottom right corner here where it says CRLF. This is how the end of line is getting noted, and we switched from CRLF to just LF. And this should do the whole trick. Run it again and see whether it works. Good. So this has worked now, and we will see each other when it's running. Yeah, so it looks like we're done. It took some time. The message that you see, I could also add and print out like a proper message that you know that you're done. But when you see the bash terminal, then you know that you're done. I'll scroll up a bit to see maybe we can find out how long it took us. Here's the runtime. It took us just 3 hours. So it's not as bad as I imagined it to be. This is an average laptop, so you can kind of expect the same times on your device. And yeah, so we're done. And when we're done, we see just the terminal here, and our outputs are obviously here in the output. One folder called print, and these are all STL files that technically they are already printable, but here we can see it's like a lot of different areas, and what we want in the end to print is the 2 brain halves as separate pieces and 1 cerebellum as a separate piece. So you don't have to print everything at once, and you can save a lot of time on the printer. And you can also print a bigger brain if you want it to be more accurate. So yeah, but for now we can close the container. We can go in here and we can just delete it, because when we delete it, we don't delete the files. And if we, for example, would have another brain in the future, because this pipe open Docker desktop, you can go already into your files, into the terminal where you've been before, like here. You can go into the folder, in the 3D print your brain folder, and open the terminal. Then you open Docker desktop, and then you can just arrow key up, and arrow key up gives you the command that you ran before that from the same folder. So it memorizes the folder that you ran the commands in, and you have already added. As long as you didn't change the folder names and the paths, you're good to go. And that's how easy you can start it. And you, of course, have to configure the script again with whatever is up here, specify the right directory, and start it. But usually, like, this is all it takes to start it back up again and to let it run once. Yeah, what to do now is we want to copy this. Copy, then I'll put it in the tutorial tab. I say like a new one for data. Then I'll open this one. I'll say a new one for subject 001. Now it's not important anymore. There's no script running. And then we can yes, now we have it copied. So it's, for me, I like to have it twice. Like we always will have it in the output folder, and I didn't remove it, I just copied it. And now we also have it in the tutorial data folder for subject 1. So if we maybe change some things and modify it, then we still have the original data now and know where it is. And now we want to open these up, but we don't have anything to do that with, and so we will install MeshLab. I'll open the browser again. We can go to the pipeline, we can scroll down and see what's the next step. And it's like smoothing the brain. And here it also has a link where to install MeshLab. And okay, so now that we have downloaded it, we can try to open the other files. Here, if you're asking what to do with MeshLab, I have here in the wiki all the steps. And yeah, so just follow these steps. I don't know if I will always show the browser view of it, but let's first open it. So now that we have MeshLab opened, we want to import our brain files. We just say import mesh. And let's first look at the whole brain. I think it's more interesting that way, and we can already see some things that worked out good and some things that didn't work out good. And I'll just pick everything that we see here. I'm holding control if you are asking how I do that. And now that way I can choose many files and select the ones in between. I'm not gonna have to do it now, but later I'll do that. And then I'll just press OK. And we can now see these objects all appear. Yeah, you can't select them outside of MeshLab and then say open with MeshLab, because then it opens like 8 times, like 8 different MeshLabs, and they're not on the same space. Oh, yeah, and now you see the brain. So this should be like your magic moment. I've already seen this brain, so it's not as magic for me, but you can take your time and be excited with this one. And we can already see like some irregularities that we don't really want to emphasize on when printing. So we want to smooth them a bit. And yeah, how to do that, I'm going to show you now. Here you can see the cerebellum. That's quite different from the brain. And also you see like these parts, they're also a bit blocky. What we want to do is to mine these. This should be like one object in the end. And then also not this. Yes, this one should also be one object. You are asking what is happening. I'm removing these parts in the middle because it feels weird when there's like a hole in there. So we kind of want to fill it with also that part, although it's not as defined. But in the print, you'll see that it will work out just fine. And then we also want to do the same for the right hemisphere. Let me zoom out. Yeah, and have that part. It's a bit, I will first close it again, and then I'll try to select another type of faces and import them right away. Mesh that back up again, and let me import mesh. But try now to import the right ones. That's why it also makes sense to look at it first so we can remember which ones were which. Let's first try to do the left hemisphere and then subcortical 17 and 18. I think these should be all in one left half, I hope. Yes. And let's first go to filters and mesh layers and go to flatten visible layers and just press apply. So we have like one mesh now. So here on the side, we can't really separate them again. And let's try to fix some of these bumps up. We don't have to fix everything because we will smooth it. And you can also preview it, how it looks smooth. Let me show you the one big smooth that we will do in the end. Before we patch, go to filters, to smoothing, and scale dependent Laplacian smooth. This is the one we want. And what we want to do is to go to 100 here and go to, instead of 1, we type in 0.1. And here it is important to not just press apply, because it's kind of difficult to go back, but to press preview. And this is how the brain will look like when you want to print it. Now you see it already looks much nicer. Like this kind of big bump and like sharp edges here. And I don't know, we don't have to remove all the bumps here, but I think let's focus on this one and let me show you how to do that. And for this, we don't take scale-dependent Laplacian smooth because it will smooth the whole brain down. And if we tinker a lot on this part, then we will shrink our brain in the process. So we'll go again to filter, smoothing, and then to Tauben smooth because this is very local. And select the parts we want to smooth, and then we will open up Tauben smooth again. And for selecting, we want to go here to select faces in the rectangular region. And here we can see the legend. What we can do, it is important to remember D to deselect everything and to press Control while adding stuff. And if you get like this weird, ugly looking brain, then you can always press here again. It's sometimes when you try to select stuff, it just defaults to this one, but this one is way easier to look at. So just do this. And here you can think about, like, imagine me selecting this. And you would think I now have everything selected. Okay, you now see I'm a bit out of bounds. But when I go away from the selection tool, I then also selected all the things behind that. And why we only want to select the surface. And let's go back to here. Press D to deselect. And read here, it says Alt to select only visible. And we hold Alt And now select. And now go back. Now we don't select everything behind that. So this is pretty nice. Now we only selected a part of the stuff that we see, and everything that we can't see, everything that's like hidden inside, that's not selected. So this is pretty nice, but you have to remember to always hold Alt and Shift. No, not Shift. Control. If we don't hold Control, then we are selecting something new, and our selection from before is deleted. So yeah, let's just start selecting this thing and hold these two buttons and just select everything that we think should get smoothed out a bit. And yeah, now it's kind of important to deselect it occasionally and see, okay, yeah, we haven't selected this whole part. And now we'll go back, hold these two buttons and select it all, everything again. I'm sure there's a button that I can press instead of. Yeah, no, I selected everything now because I pressed this instead of this. So we'll see each other again. We do really want to be thorough. If we don't select like some stuff, then we're going to have like a floating polygon after we smooth everything out. In the best case, in the worst case, like it looks really crooked. Yeah, looks fine. I'll select a bit more on the edges so it has like something to smooth into. So it can like kind of follow the curvature of the object. It looks like we have most of it kind of covered. And now we have the selection tool deselected, so we don't select anything on accident. And then we'll just go to filters, smoothing, and Tauben smooth. And here we can just let it give us a preview. And this looks way better than before. We don't have like this huge bump, but I'm still not a huge fan. You can now play around with parameters and see maybe lambda changes something. Well, I think this is better, but it's still not perfect. Keep in mind to play around with the preview because Control Z doesn't really work in here. That you can tweak it how you like, and the kind of has like 3 or like more like 2 parameters that you can change and move the bumps. Then you don't have to be that thorough, but for me this is more than enough. If you have like another bump, you just select it again, do the Tauben smooth and change the parameters. I don't know, I'll try to change something so you can see more. Maybe I like this one more, but I'll try to change it up a bit so you can see maybe what different parameters do to it. This one doesn't really change much. So it's maybe better to keep this one small. Yeah, but yeah, I think this one's good. And with it, one is not to apply it before you're happy. Just first. And now we've applied it. Now we can also deselect the preview, and this is how it looks now. We can now go to the selection tool and select it, and then it doesn't look as bad. And now we will do the whole brain smooth. So yeah, we go to filters, smoothing, scale dependent Laplacian smooth. We give it like 100 steps and make it a little bit less effectful and let him give us the preview. And I think this one is kind of good. We don't need any more steps. It's enough, but this doesn't really matter in print. So like see something really unnatural and big that you don't want to see on the brain. When you have it printed out, then everything is fine. And ready. we can press apply. And yeah, then we go to file. We go to export mesh. And now we can name it. Now I just go to, I usually like to do something like LH final. And go to STL file format. Thing that we want to feed into our cruiser slicer or like a printer slicer program, and save it. And we will say that we don't want materialize color encoding and leave binary encoding just like that. And we'll press OK. Now that we've done that, we can check whether it worked. I just go to MeshLab, open it again, do files, import mesh. This is how it looks like. This is how we saved it. Everything is fine. We can put it into a print folder. And now I'll do also the second half and the so you can see what to press on this one, because as you saw, it looks a bit different. And we'll see each other at the cerebellum. So now we are at the cerebellum, and we want to import that because it's a bit different. Which ones were the cerebellum? These ones and these ones. Perfect. Looks a bit usual, but we'll do the same thing first. We'll go and where is it? Flatten visible layers. We press apply. Now all in one layer. Now we go to filter, smoothing, scale dependent Laplacian smooth. And here we can, the thing is we can go not 100, but 175. You just put like, what is that? I'm just doing it for like showing purposes. So I'm not going to fidget with it a lot. But this one looks fine. And the main thing that we want here is that it looks kind of similar. So it's not like something entirely different on there, because it still looks like a bunch of cubes. But this one looks decent now, and you don't really see the cubeness anymore that much. And you don't, for me, this is good. So I just pressed apply, and I'm happy with this. And we'll see how the printer handles it. But as long as you don't have like any holes or anything, any unusual things that you have to fix, then it is pretty easy. If you have something, then you can just try the Tauben Smooth again or do something else, because MeshLab has a lot of tools, but for us, we usually only need Tauben Smooth and scale-dependent Laplacian Smooth. And yeah, so we will export it like we did before. Export underscore final, because I know what to print if it has final behind it. Do this again as usual. And now we can look at the whole brain, how we've processed it, and how it will look ideally then in our hands after we have printed it. Okay and okay. We'll see whether it will give us an error when printing, but usually it doesn't. So long as it looks like a brain in here and you don't have like any too weird errors when putting it in the slicer, because this is actually what counts, then you can just print this. If you have like some errors, there are many resources to look at how to make an STL file printable when you have like some errors, because now it only is an STL file and you don't have to think about the pipeline, you don't have to think about FreeSurfer and whatever, how they do stuff. Now everything that applies in regular 3D printing applies from this point on as well for this brain. So I hope you enjoyed this run through, and questions, you can probably somewhere find my contact and contact me. And if I can answer them, I will try to, but I've put all of my knowledge in here and in the GitHub, so you can look there first. And yeah, that's kind of it from me. And happy printing. Yeah, now that we came to an end, I want to thank everyone who participated in it, because this is, of course, not work for me alone. I was inspired by a lot of other GitHub repositories. I was inspired by all the people who did it before me in the university, in the Print Your Brain course. And of course, this couldn't have been done if we didn't have the printer and didn't have all the organizational forces. So thank you everybody who participated, and I hope we will have many more contributors in the years to come. And yeah, I hope you've gotten your STL file and you're ready to print. And see you next time.